Hello, and thank you for joining today's webinar. I'm Lucy Hodes, Senior Vice President of Media and Communications for CCA, and I'll be your moderator. I hope everyone's doing well. Today's webinar is The Path to 5G Profitability, and it's sponsored by Mavenir. We have a very interesting discussion planned about the changes we can expect as 5G begins to take hold, and we have 3 speakers. I'll first introduce Brandon Larson, who is Senior Vice President and General Manager of Mavenir's Multimedia Business Unit. Brandon has diverse experience, having held roles in sales, marketing, product line management, and program management. Next is Dejan Leskaroski, who is Head of Product Management at Mavenir. He leads product-related activities as part of the Mavenir Packet Compute Business Unit, including the Mavenir Virtualized Evolved Packet Core and the Mavenir Fully Containerized 5G Core. And we are also joined by John Baker, Senior Vice President of Business Development at Mavenir. John leads the 5G team at Mavenir and is at the forefront of the company's drive to change operator views on wireless infrastructure deployment, promoting a software-focused approach to innovation with no ties to supporting legacy hardware. John's also one of our keynote speakers at CCA's upcoming virtual mobile carrier show, so please make sure to tune in then as well to hear his remarks on Open RAN. For those of you in the audience, if you have any questions throughout the presentation, please submit them at any time and we will get to questions at the very end. Also, today's webinar is being recorded and it will be available on CCA's website after it's over. Now, Brandon, I will turn it over to you.
Yeah, thank you, Lucy. So go ahead to the next slide, Allison. So with the arrival of 5G, there are going to be a lot of changes across the entire mobile ecosystem, which is no surprise. So in today's webinar, we're going to cover topics that span the entire network, from radio to packet core to voice services. So I'll start off by discussing how voice services will evolve with 5G core and radio. Then Dejan will discuss the benefits of having a converged packet core to be able to simultaneously support both 4G and 5G services out of a common core. And then John is going to give some insight on where the industry is with Open RAN and some of its benefits, big one being interoperability. In fact, Mavenir Radio is already deployed and operating with both Ericsson and Nokia radios out in the market, so the interoperability is already proven. And then throughout the webinar, we'll touch on how all these workloads are being deployed in container environments, which provides the latest advancements in automation. Next slide, Allison. Go ahead to the next one. So we want to start with IMS. Now, IMS is essential in the 5G standalone environment for voice services. So initially, 5G standalone deployments won't support voice. What's going to happen is the NG RAN or 5G radio, that's going to trigger redirection or a handover to VoLTE when it gets a bearer request for IMS voice. So you're going to need a VoLTE network day one to support 5G standalone deployments if you want to have voice in the network. Now in 3GP release 15, there was no fallback mechanism defined from 5G to 3G. So the mechanism is currently being defined as effectively a two-step fallback. So first you have to have a 5G to 4G handover using N26, and then a 4G to 3G SRVCC procedure. So even though in theory this is going to provide a solution to fall back from 5G to 3G, it's going to be very clunky. It's going to require an inner working function, and that two-step procedure going from 5G to 4G, then 4G to 3G is going to be expected to produce a lot of latency and have a bad user experience. And when voice is finally supported on 5G standalone networks, it's going to use the same IMS core as VoLTE. So there's going to be a single IMS core deployed with a single set of services. So you're going to have service parity, whether you're delivering those services over the 4G or 5G, and there's going to be seamless mobility between them. So go ahead to the next slide, Allison. So, in terms of other options, there is an intermediate or stepping stone into getting to full voice over an hour with a 5G packet core. This intermediate step is known as option 3X non-standalone. And in this deployment, a 5G radio is going to be deployed alongside an existing 4G packet core, which is already connected to the IMS core providing VoLTE services. So here there is no change in the IMS connectivity to the packet core, so this minimizes disruption to the IMS and voice services and makes this implementation a little bit easier from an IMS perspective. There is, however, some IMS modifications to handle new access type, and I'll cover those in the next slide. And as this evolves to 5G standalone, there are more modifications to how IMS is connecting directly to the 5G core and how the IMS HSS is connecting to the SDM layer. So, specifically touching on the IMS modifications for option 3X, the non-standalone option, really it's about adding 5G access awareness to the existing IMS paradigms. And that's being done by adding information, what they call the PANI header. So this is a header that indicates which access technology is being used by the UE. And this is used to distinguish access types for things like KPI performance management, billing, troubleshooting, as well as some of the service logic is going to be dependent upon access types. So this PANI information is going to be collected by the access SBC at multiple points in the call flow, such as registration, the start of the call at the invite, can be updated during the call or at the end of the call, or it can actually arm triggers with the 5G core, letting it know that, hey, an access is has changed, and then this information can be stored by the SBC and then sent upstream to the other nodes in the network. So go ahead to the next slide, Allison. Now, in terms of the initial deployments of standalone, it's going to leverage the access awareness we just discussed in the previous slide. And in this scenario, traffic is going to move from the SGI interface coming from a P gateway to the N6 interface coming from a UPF. Not too many changes for IMS other than, the traffic is going to be coming from a different node. Policy is going to be provided by the PCF. Now, initially, connectivity can be done using existing RX interfaces and procedures that are available today. PCFs are typically backward compatible in the market. So this removes the dependency for an ASBC upgrade to get voice working initially on 5G networks, and this will help accelerate deployment. And then the other aspect is there's a discovery mechanism that needs to happen between the SMF and the PCF in the 5G core and the SBC. Initially, static mapping, like is used today between a P gateway and access SBC can be used. Again, this will help accelerate deployment by not having to go to more sophisticated NRF discovery mechanisms right out the gate. And then on the SDM layer, the HSS is going to connect to the 5G core UDM UDR. This will be over newly implemented REST interfaces called NU1 and NU2. And these interfaces are going to be mainly used to harmonize authentication between the 5G network and IMS, as well as retrieval of the information for terminating services by IMS nodes, such as the TAS. Let's go to the next slide, please. So, later on, some more sophisticated procedures can be put in place in terms of policy and discovery procedures. Specifically, the NRF-based discovery mechanism will replace static IP configuration. So this is where the SBC will now be able to register with the NRF, and then the SMF can invoke those NRF services to discover the SBC. And the PCF can also register with the NRF, where the SBC can invoke the NRF to discover the PCF. So, with this NRF discovery mechanism, different nodes can register with different information, IP address, UP ranges, location information, license information, et cetera. And so this enables a broader selection of criteria for the selection of services. So you can, offer more sophisticated use cases, around discovery. And then in terms of policy, the N5 is going to replace what was the previous diameter RX-based interface that exists in VoLTE today. And then the SBC is now going to become a consumer of 5G core or MPCF policy services to set up dedicated bearer for QoS. And this is going to allow a much greater range of QoS setup for IMS than it currently exists today in the 4G domain. Let's go ahead to the next slide, Allison. So, what I just covered is really kind of the plumbing of the network in terms of how IMS connects to the 5G core and the different protocols and procedures that are going to change. The other big change that's happening is the move to containers in the cloud environment. So, 5G core workloads are really providing the driving force behind the move to containers in Kubernetes environment today. This in turn is really driving all workloads in containers, not only IMS, but also, messaging workloads as well. And the reason for that is because the goal is to have a common cloud infrastructure with operations harmonized across a common CI/CD pipeline and automation framework. So some of the key value benefits of having, all workloads working on the same environment is one, you'll have radio, packet core, IMS, messaging workloads, all sharing the same compute hardware, network, storage, cloud infrastructure, and this is going to reduce the overall CapEx burden. These workloads will all be packaged in a common artifact framework such as container image, Helm v3 charts. They'll be delivered to the same repository and they'll be deployed, updated, and maintained using the same CD pipeline. So this harmonizes the end-to-end network operations, making deployment, upgrades, configuration changes across all these different workloads more efficient. And lastly, all these workloads are going to plug into a common observability framework, which this will enable you to have all the network information in a common place, which is going to enable a more holistic end-to-end view of services, allowing the operators to make more targeted and intelligent decisions in managing the network. So with that, I'm going to turn it over to Dejan now, and he's going to talk more about the benefits of having a converged packet core.
Thank you, Brendan. Hello, everyone. In the next section, what we'll cover is the Mavenir converged packet core portfolio. We'll focus on the 5G core components, but at the same time, what we'll also cover is how the same architecture used for the 5G core also supports backwards compatibility to 4G, as well as 2G and 3G, which is applicable in some regions of the world, but also does convergence when it comes to non-3GPP 3GPP access, Wi-Fi access, as well as fixed wireless access. From a portfolio perspective, so everything you see here, from portfolio perspective, it's containerized. Mavenir made a decision that as we were building this next generation of packet core, that we're going to start with true cloud native, granular microservices running over Kubernetes platform. We have a lot of common layers that Brendan touched on, and John will cover as well across our IMS product, our packet core, and Open RAN. From a converged packet core perspective, even our SGSN and MME SA gateway are containerized, so there's no need, for example, to deploy any function in virtual machines if not required. This actually simplifies the overall operation of your network, orchestration, and everything else. In addition to that, our 5G core components like SMF and UPF, so your control plane and user plane functions on the 5G core side, also have integrated 3G and 4G access. So you, in addition to 5G, you actually get separation of control plane and user plane within those functions for 3G and 4G coverage. And then we have a full portfolio when it comes to the 5G functions. So AMF, NRF, NSSF, SCP, BSF, AUSF. So that kind of completes the whole picture from a 5G core perspective. The other complementary products here are on the non-3GPP access. So one big difference in the 5G world, it's really to converge not just 3GPP access, but also actually to have convergence on Wi-Fi access as well as fixed wireline access. So basically have one core for all use cases. In addition to that, we have a suite for cloud IoT, both for SCAF and NEF. So having a combo support for IoT, as well as SMSF function for messaging. So that's from a packet core perspective. Additional components that are part of the end-to-end solution is subscriber and data management. So this includes things like UDM, UDR for the 5G core side and HSS for 4G. We also have a UDSF, so we rely on a centralized database to store all state data. This allow us for all the microservices which are part of each network function to be truly stateless. And UDSF has a distributed database with geo-redundancy. So you kind of get the benefit of having a truly stateless microservice architecture. And the last thing is from policy and charging. a CHF for online and offline charging for 5G, a combination of PCRF and PCF for policy, as well as a CGF for offline charging. So that's kind of the whole layer of different pieces. Brandon touched a little bit on this in the previous slide. We do have a common framework when it comes to CaaS and PaaS, containers as a service and platform as a service components. This is the Mavenir Web Scale Platform, was for short MWP, as well as a integration layer. We have a common integration layer that provides a single API, for example, a common API for configuration, common API for fault management, for low fault intercept, high availability. So that way, instead of actually having to integrate with multiple network functions, you have single APIs to integrate with your management system, your network slicing systems, or your higher level OSS BSS systems. You can go to the next slide. So in the next slide, what this slide shows is kind of how everything fits together. Now this particular diagram shows 4G and 5G, but in addition, as I was mentioning earlier, 2G and 3G as well as the non-3GPP access is supported. So we've highlighted kind of the key components where combo functionality is important. The main one are around the SMF and UPF. So within the Mavenir SMF, both SA Gateway C, so this is your S Gateway, P Gateway control plane, as well as the GGSN, it's integrated. Because of the nature of how 4G and 5G works, on the 5G side, everything is based on the 3GPP defined SBI interfaces. So that gives you the capability of having the SMF integrate with your CHF, UDM, UTR, PCF. But because many customers may not deploy 5G core just as a standalone deployment, or there will be a lot of brownfield deployments, or there will be a migration of 4G traffic. We also support diameter interfaces. So that's why you see the GX and GY interfaces, where your converged core, if required, can integrate with an existing OCS or an existing PCF. The other thing I'm going to highlight is on the UPF, same thing here. We have a single UPF that actually processes 4G, 5G, and 3G packets. So it's a combined combo UPF that it's able to support all the different Gs. On the MME and AMF, although these two components are separate, they're fully containerized, so they actually can be co-located, running in the same environment. And then there is an N26 interface for interoperability. The last thing I want to touch on this, because it is also important, is on the UDR and HSS. So depending of how customers are planning to deploy their 5G core, they may have an existing HSS. In those cases, it's important to be able to leverage that and integrate with the UDR. Or if it's a truly greenfield deployment, the capability we have is that you can have a common subscriber database that can be accessed both by the UDR as well as by the HSS. So again, just kind of to give you a full view of how everything fits together. You can go to the next slide. So from a deployment standpoint, there are different options. And of course, every customer, we've been engaged for the last 2+3 years with customers in different trials, and almost every customer has a little different requirement in terms of how they want to deploy 5G, and then what use cases they want to focus on. So of course, you can deploy 5G as a purely standalone functionality. So you can have 5G SA that runs side by side with the existing EPC network, and address use cases, either consumer use cases for 5G SA, or maybe SA use cases around IoT or enterprise. The other use case we've seen, which actually is common in not just in the US, but Europe and APAC, is customers are looking to start investing in the next gen architecture. So in this particular case, they can start deploying the new containerized architecture, but actually use the new network for EPC offload. So basically using your new 5G core to serve 4G traffic. Instead of kind of continuing to invest in a legacy network, start actually building up your converged core. And at the same time, actually do 5G NSA. So that's another type of use case. And of course, you can actually combine everything. Scenario 3, you can have 5G SA, 5G NSA, and 4G offload in the same architecture. And lastly, there's a lot of movement. Of course, 5G is not just about the consumer model, but also it's kind of enabling massive IoT. So being able to deploy the core for IoT and then leverage the Mavenir NEF and SCAF functionality for those services. So again, deployment options are across the board. As I was mentioning earlier, even our 2G, 3G functionality is containerized, and the same is true for Wi-Fi access, either being ePDG TWAG or entry WF or interoperability with the fixed wireless access as well. So the last slide on the packet core. So just kind of from a summary in terms of what are the key differentiators from a Mavenir packet core perspective and how they're driving lower TCO. One thing is automation. So this is on multiple layers. One of the reasons of moving to cloud native and containers is there is a lot of tools and capabilities at the Kubernetes level. So think of anything from easier deployment, healing, auto-scaling, management. A lot of the lifecycle management of the container framework that has been adapted and used by many years by other industry have been adapted into the telco world. So the way that lifecycle management is being done on your network, it's much easier. Things are stateless and easier to do. On the higher level, it's having commonality. So open APIs, standard APIs, common management across core, IMS, and RAN. I did talk about converged core, so I think I'll skip that piece. I think the last couple slides cover that. Granular microservices. So it's not just about saying that yes, our solution runs in containers. It's important to understand how this is actually done. If you take VM software and move it into containers, and each microservice is 5, 6, 7 gigabits of image size, it will take long to spin up these microservices. If you have a true granular microservices, the spin up time and it's much reduced. How you upgrade in terms of canary upgrades, how quickly you heal or scale, and also how you can actually pack the microservices onto your resources. So Kubernetes has a very high efficiency when it comes to packing and deploying the containers within each compute node. On the right-hand side, platform agnostic. We talked about the Mavenir platform, but also we can run on, and we have been integrated actually as part of customer activities with VMware, with OpenShift, as well as running on public cloud. When it comes to use cases, the nice thing about the Mavenir platform is we provide everything that all products are developed in-house. So the same packet core can actually scale down and be used, for example, for NPN or MEC type of use cases, or can scale up for consumer and IoT use cases. There's no separate software for enterprise versus consumer. The same core, the same software, the same components apply for all. And lastly, on the user plane, we've done a lot of work here because obviously, throughput is increasing every year. Being able to really shrink the amount of footprint that the user plane takes and the throughput that a single unit can do. We recently published a white paper on this in terms of being able to achieve 524 gigabits on a single user plane using 16 packet processing P cores. This was done with collaboration with NVIDIA, where we will actually able to offload some of the user plane processing onto the SmartNIC and reduce the footprint of the UPF by 50%. So with that, I will turn over to John.
Yeah, thanks, Dejan. And the great thing about Dejan going before me, he's actually covered a lot of the virtualized aspects of how that all applies to Open RAN going forward. So great job there. And what I'll try and do is cover very quickly what's going on in the marketplace, and how Open RAN really sort of adds on to the virtualized platforms that Brandon and Dejan have been talking about. But the whole excitement in the industry, and I won't go in detail here, this slide is in here for reference, but the whole excitement in the industry is about opening up one interface essentially between the radio and the BBU. And opening up that one interface is essentially reinvigorating the telecommunication space from a RAN perspective, and opening up the opportunity to many different vendors, and country by country it's becoming a geopolitical discussion about the future of Open RAN philosophy moving through into telecom networks of the future. So if we move on to the next slide. We're already seeing the fact that 23 plus mobile operators, and this slide represents all of the Open RAN vendors currently in the marketplace. So OTSR, Parallel Wireless, and Mavenir. And this slide is actually changing daily, but 23 plus operators, 1 billion subscribers covered, with plans effectively either active Open RAN networks or Open RAN networks in deployment. And really the largest deployment going on with a Mavenir customer is Dish, out of Denver, and we'll see those networks launch this year, but that will be the largest 5G Open RAN network being deployed on a global basis. Next slide. So again, you look at the logos, and this really sort of reinforce that Open RAN is becoming a reality. It's not in the technical specification space anymore. It's not in the lab space as much as others would try and tell you. It is there being deployed commercially and trialed commercially on a global basis. And you see the logos here. It's majority of the tier 1 operators on a global basis. And that really sort of cuts through some of the noise that you hear in the marketplace, and the noise is sort of being generated by vendors trying to hang on to market territory. But in reality, all we've done is open up one proprietary interface that's allowing operators to look at other vendors, and clearly those current incumbents can all play in this as well. Open RAN's all inclusive. And this problem wouldn't have existed if the current OEM vendors had opened up that one interface and other interfaces to allow a mature market to compete on competitive terms. So we go to the next slide. So the other piece behind this as well, and Mavenir is very active in the board of the Open RAN Policy Coalition. And actually today there's 62 members across 11 countries, and we have the tier 1 operators from Europe, 3 of the tier 1 operators in the US, the objective is really just about pushing and promoting open interfaces that are interoperable. And those two pieces go together, that it's all about interfaces that are fully defined, such that competitors could go build product, and then the ability to interwork those products, so that the operators, such as some of you would actually go buy from different vendors, and with confidence that you're going to get the network performance and technology performance that you need. And this has been demonstrated by multiple plug fests that have gone around the world last year. I think 57 companies participated in 3 regional plug fests, from Japan, India, and Germany. We're demonstrating the interworking of Open RAN products. Next slide. So again, there's some sort of confusion around the Open RAN ecosystem, but ORAN, which this is really a group led by, I think, 12 operators, and really focused at cleaning up the specifications that got left from 3GPP perspective as just framework specifications, and work completed on the open front haul interface, which is the interface between the radio and the BBU. But there are many new innovative specs that are being generated as well for new products that are going to come down the line. So again, it's very much, specifications are complete and they're tested, and products are coming along for the radio piece of this. Things like the radio controller, white box radios, and other things are all in the specification process. But those specifications are futuristic in the sense of new products, new innovation ideas, and will come for deployment later on down the line. But that's really what Open RAN gives you. It gives you the ability to plug and play. You take the advantage of the best technology in the world, the lowest cost technology in the world, and from an operator perspective, then diverse roadmaps. You're not pinned to essentially a roadmap that every operator gets at the same time, same technology, and from a price perspective, everybody is getting it at similar prices with similar pain as well. So that's the benefit of Open RAN, Open RAN and O-RAN. The telecom infrastructure project, started, back in 2016, has really sort of focused on this philosophy of Open RAN, very much, looking at similar things that's been going on in O-RAN, but really more about the development, test, and deploy aspects of those products. So a lot of initiatives there in terms of radios through, the Even Style product. Mavenir is leading one of the Even Style programs and brought a new radio to market, so we can address low-cost radios, and then other things like the DU, CU in terms of COTS hardware platforms to run company software on, and then obviously the Open RAN Policy Coalition that's making a lot of headway around policy and on a global basis, and how countries and should view bringing Open RAN in to diversify the supply chain, and this is really what it's about. We've gone from 10, 15 plus suppliers back 10, 15 years ago, and now down to essentially 2 suppliers, almost acting as a cartel, in the marketplace. So again, it's from an operator perspective and industry perspective, it's really about opening the supply chain and diversification. Next slide. So if you look at the Open RAN ecosystem, and it's actually quite straightforward. You've got the BBU, as you know it today, being replaced by a virtual DU and a virtual CU now. As was said earlier, that that these containerized software elements can run together on the same platform. So you don't need that mid-haul split to interface being physically connected between the two. It can be logically connected on a single platform. And then the O-RAN interface, which is known as also the front haul split 7.2, can connect to a diverse portfolio of radios. And we've tested against multiple radio manufacturers for 4G and 5G, have deployments around the globe with 4G and 5G product. And later this year, we'll also be launching a 2G and 4G compatible solution, as Dejan said, with effectively equivalents of Open RAN 2G and 4G, 5G, all running on the same platform. The other important piece is that the front haul split, in the way that it was designed, will support sub-6 frequency bands, everything that you see in the marketplace today, right down to 600 megahertz. But we're also now launching millimeter wave product at the 28, 29 gigahertz band using the same front haul split. So once you deploy a software-based solution, you're open to whether it be millimeter wave, sub-6 frequencies, in-building, macro, small cells, you can all run on that same architecture without having to worry about building new platforms for different applications. So it's really a plug and play type scenario for different radios. Next slide. So again, this slide really sort of depicts the whole story, and in terms of a deployment of an Open RAN network, and this is quite a large architecture in a sense of showing the different backbones between CU, DU. If you were a major carrier with high capacity, you could take advantage of co-location of DU, CUs, etc. And run transmission networks between them. But if from a small carrier perspective, and this goes right down to deploying in the enterprise, I can put my CU, DU, and all my EPC functionality essentially on one blade of a server. So, the whole Open RAN architecture is very scalable, from supporting tens of subscribers, one radio, right the way up to hundreds of millions of subscribers, and hundreds of thousands of cell sites. So, it's supportive of MIMO technology. Again, I think there's a lot of noise in the marketplace that you can't do massive MIMO on Open RAN. Well, that's again not true. You can support all the MIMO configurations, right the way down from millimeter wave frequencies right the way down to sub-6. So, I think it's important as well to recognize that Open RAN is not a revolution, it's an evolution. As I say earlier, all we've done is open up one interface and then virtualized the BBU so that it could be split architecturally. You can get interfaces into the DU, so things like common schedulers and other pieces of the network, and access into what we call a radio interface controller, such that you can get precise spectrum management, precise subscriber management, as from right down at a subscriber level at a cell site, scaling up right through to the major deployment in the network. Next slide. So to summarize, last slide here, as much as some of the noise is in the marketplace, Open RAN is mature, and when I say by mature, it's as you see from the examples from Dejan and Brandon, that people have been employing virtualized elements in their networks for 10+ years, and today we have elements out there carrying hundreds of millions of subscribers on single network architectures. So there's nothing new in terms of virtualized networks. Obviously technology is advancing with containerization and speed of processors, but that's a natural roadmap that any technology vendor would be addressing. So again, there's really nothing new in terms of Open RAN and virtualization. What we're also seeing is that, again, much to the news that may be in the marketplace, that power consumption of virtualized RAN is actually better than the legacy RAN, and this comes about primarily due to the clock speeds and interfaces that are now Ethernet. There's no need for dark fiber in the network. The clock speeds are running at a quarter of the clock speeds of the existing network infrastructure. But the other big issue, the other big thing that was designed into the specs, when there's no traffic, there's no bandwidth, or no requirement for bandwidth. So in that sense, the network is switched off when there's no traffic running there, and this gives you another ability to essentially share virtual elements across cell sites and gain that cost benefit. So you automatically start to see cost benefits and 50% saving almost if you start to take the extremes of the numbers across cell sites when I'm sharing VNFs. And so from a power consumption perspective, is that in reality the radio has not changed. The radio is exactly the same as the radio that you have on the tower today. You can have a CIPRI interface, and now the new ORAN interface can be software uploaded into those radios, and so from that perspective, there is absolutely zero change on the radio technology. Open RAN is allowing different radio vendors to come to market with new technology, and you'll be hearing about massive MIMO and things later on in the year, but all of this is coming along, and there will be a competitive marketplace in the radio space. And then the ability to use virtualized technology on COTS platforms, off-the-shelf compute platforms, means that I don't have to wait 18 months, 2 years for somebody to develop a piece of silicon. I don't have to wait to get my order into the supply chain and wait half a year for it to be delivered. I could live on the back of the IT industry for compute platforms, live on the back for new processor roadmaps. And over the last 3 years, as we've been developing the product, we've already seen 3 processor revisions in terms of cost, capacity, and size. So we're getting 4 times the capacity improvements just on a single processor release. So you've got a natural capacity roadmap that's being followed by the silicon vendors, and then that's divorced, if you like, from the software vendors, and the two worlds can live independently. So you can get software improvements on one side, I can get technology improvements on the other, and then take the capacity and cost advantages as those technologies get deployed. And then lastly, but not least, as we said earlier, investment and innovation in the Open RAN space is now growing. And I always use an example of when we started this journey 3 years ago. You look in the marketplace and see 2 radio suppliers. And now, I think as the last count, there's potentially 17 companies looking to produce radios in different frequency bands on a global basis. So, that's driving volume. So there should be, at the end of the day, no real price discrepancy in any of these components. And, it's also driving the fact of higher levels of integration. And, this is being demonstrated by the work that Mavenir has been doing with Facebook on the Evenstar radio program. So, very, very high level overview of what's going on in Open RAN. Certainly very pleased to talk more about this at the coming event, with a keynote presentation, but really just sort of giving you some highlights here. So from that perspective, I'll hand you back to Brandon and Dejan, and we're open to questions.
Great, thank you all very much. Reminder to those of you in the audience, if you have any questions, please submit them. We've had a couple come in, so I will jump right in. Our first question: what is the timing you see in the market for voice over new radio actually going into production?
Yeah, Lucy, I'll cover that. So in terms of market timing, I mean, we've already started delivering both the option 3X non-standalone as well as the option 2 standalone to labs last year. So, testing's been going on probably since, mid of last year. Right now, we have customers continuing to test voice over on our solutions, and this is using our full kit radio, packet core, and IMS. But in addition to simulators, which were kind of used last year, we're also now bringing in the devices to certify an end-to-end solution. So that's another sign of maturity. And then we're talking to our operators. They're looking to probably deploy voice over in our option 2 standalone by the end of 2021. So, if I kind of look at, read the tea leaves, I think we'll probably have some FOAs by the end of this year, and it'll start ramping up in 2022.
Great, thanks, Brandon. Our next question that's come in: when it comes to 4G, 5G convergence core, what are the most important network functions where 4G, 5G combo support is required?
So I think I can take that one. So I think that it will depend on the type of use cases, but at a minimum, the most important pieces is the SMF, so your control plane in terms of session management. I touched a little bit on that when I talked about. So the SMF, by SMF having SA Gateway C functionality, which you will assure there that you're going to have seamless mobility between 4G and 5G. So the session will be actually anchored on the same network function. So you do not have to actually move between an SMF, which is a standalone SMF, and a standalone SA Gateway C. When they're running as a combo node, then you have seamless mobility. So that's one important piece. The second important piece is the UPF, the user plane. So having a user plane that can support both 4G and 5G. And so that way, when subscribers go between 4G and 5G access, you have that. So those are the two key things. I think other things that are important have to be taken into consideration, but this will depend on how customers deploy their network. PCF and PCRF. Obviously, if you are existing network and you have a PCRF existing, you want to actually make sure that there is a proper integration between the PCF and PCRF. That's why the SMF should be able to support diameter interfaces. But if not, it's a greenfield deployment, then you want to have a combo PCF, PCRF, so you have one network function. And the same is true for HSS, UDM, UDR. When it comes to subscriber management, if you're deploying a new network, you want to have a common subscriber management. I would say even if you have two networks, you want to have a evolution path where you have a common subscriber database between your HSS and your UDR as a evolution path.
Great, thanks, Dejan. I see that we've come up on our 45 minutes for the webinar, but before we close out, I just wanted to ask the panelists if you all have any final thoughts before we close out for today.
John, I'll just leave final remarks that as you see from Mavenir, you've got a complete portfolio offering. You don't have to have the complete portfolio essentially to deploy networks. As Brandon said earlier, this is commercially deployed on a commercial basis and interoperable with all the vendors around the world. So and we're happy to sort of answer any inquiries. But Brandon, any other points you'd like to raise?
Yeah, I mean, first I'd like to, thank you for inviting us to share our experiences, with the audience in the CCA, and maybe just kind of confirm John's statements. There is that when we look at 5G containers, voice over NR, I mean the timing is now, right? For market, I think you wind the clock back 12 to 18 months ago was something that was more into the future, but now we're really seeing the device ecosystem coming along. We're seeing customers take all the Mavenir technology in the lab, putting it through its paces with plans to deploy. So I think the time is now for operators to look seriously at evolving their networks to 5G.
Great, thank you all. I really appreciate your participation today. Thanks for that great information. Thank you, Mavenir, for sponsoring. And this concludes our webinar, and I hope everyone has a great rest of the day. Thank you very much. Goodbye.
Thank you.